In this section, we're going to look at solving linear functions. We're going to do a review on how to solve equations before we get to the function part. If we look at the equation 2x minus 1 equals 3, remember the goal is to get the x by itself. We need to get rid of all add and subtract first. Since we have a subtract 1, we're going to add 1 to both sides of the equal mark. What you do to one side, you must do to the other side of the equal mark. This is going to leave us with 2x equals 4. At this point, the only thing attached to the x is the 2. It's attached by multiply. So to get rid of multiply, we're going to divide both sides by 2 and find out that x equals 4 divided by 2, or 2. Remember, you can check these equations by going to the original problem and substituting in your variable. Instead of 2x minus 1 equals 3, we'll have 2 times 2 minus 1. That's 4 minus 1 on the left-hand side, or 3. Notice, as long as your left-hand side equals your right-hand side, you know you've solved the problem correctly. Now let's look at 4 minus x equals negative 5. The goal is to solve for the x. We're going to get rid of the 4 first. To get rid of a positive 4, we're going to put a negative 4 on both sides. That's going to leave us with the negative x is equal to the negative 9. We need a positive x, so at this point you can multiply or divide both sides by a negative 1, leaving us with negative 9 divided by negative 1, or a positive 9. Realizing that in our check, 4 minus a 9 equals negative 5. 4 minus 9 is negative 5, so left-hand side equals right-hand side. Moving to a little bit more difficult equation, let's look at what happens when we have x's on both sides of the equal mark. You always need to move the x's to the same side. So I can do this by subtracting 10x from both sides. The left-hand side would then be negative 3. The right-hand side would be 8. Notice that your x's, or your variables, dropped off on both sides. At this point, negative 3 equals 8 is false. That is not a true statement. When your variables drop off and what's left is false, your answer is going to be no solution to this problem. When you have equations with fractions in them, you need to clear fractions by multiplying both sides by the least common denominator. But always clear your fractions first. If we look at our denominators of 6 and 3, the least common denominator of both of those is going to be a 6. So I want to multiply both sides of this equation by 6. Left-hand side, we did the distributive property. 6 times 8 is going to be 48. If we multiply 6 times this negative 2/3, notice we can cross cancel. We have a negative 2 times 2x, or a negative 4x. And on the right-hand side, the 6's will totally cancel out the fraction, leaving us with just 5. At this point, we're going to subtract 48 from both sides. That will leave us with a negative 4x equals a negative 43. Get rid of the negative 4 since it's attached by multiply by dividing both sides by a negative 4. And x is going to equal a positive 43 over 4. We can check this one on the calculator. If we go into the original problem and substitute in 43/4, we'll have 8 minus 2 divided by 3 times our x, which is now 43 divided by 4, and hit our enter. We'll get a fraction or a decimal there. We want to change that to a fraction. Make sure it equals the other side. To change a decimal to a fraction, we're going to hit math, enter, enter, changing that to a fraction, and you'll notice we do come up with the correct answer of 5/6. Going to our next problem, when we have distributive properties, you need to clear the parentheses first. On the left side, we're going to do 3 times the x and 3 times the 1, leaving us with 3x plus 3. On the right side, we're going to have to distribute the negative 2 across the parentheses. Negative 2 times 3x is negative 6x. Negative 2 times positive 4 is negative 8. We're going to combine our like terms on the right side of this equation, combining the 5 with the -8 to give me a -3 minus that 6x. At this point, you'll notice we have x's on both sides of the equation. We need to move the x's to the same side. I can do this by adding 6x to both sides, leaving us with 9x plus 3 will equal a -3. Getting rid of the positive 3 on the left side by subtracting 3 from both sides, that will leave us with 9x will equal a -6. Dividing both sides by 9, leaving us with x equals -6/9. Now, if you're not sure if the fraction's going to reduce, your calculator can help you with this. On your calculator, if you will punch -6 divided by 9 and hit Math, Enter, Enter, it will always reduce your fraction for us. So our final answer here is going to be x equals -2/3. To do the check, I'm going to bring up the calculator again. I'm going to plug my answer into the left-hand side, or 3 times the parentheses of -2/3 plus 1. So my left-hand side is going to equal 1. My right-hand side is going to be 5 minus 2 times the parentheses of 3 times my x, which is -2/3, so -2 divided by 3, and then adding 4 to that. And you'll notice that the right-hand side is also 1, so we know we have the correct solution. When we're supposed to solve for a specific variable, you want to make sure that that variable ends up by itself. In the case of 2x minus 3y equals 6, if you want to solve for y, that means we need to get the 2x to the other side by subtracting 2x from both sides. That's going to leave me with a -3y equals 6 minus 2x. The only thing left to get rid of is the -3, and it's attached by multiplication. To get rid of multiplication, you're going to divide. So dividing both sides by -3, getting the y by itself is going to be 6 minus 2x, all divided by -3. One last example on that. If we have the equation, excuse me, let me go back to that page. If we have the equation of A equals B plus BCD, and we're solving for B, we want to get the B by itself. Notice we have two terms with the B in it that we cannot combine because they're not like terms. So at this point, you're going to have to factor the B out of the right-hand side. B times 1 is going to give me B, and B times a positive CD will give me BCD. Now I only have one B. It's attached to the parentheses by multiplication, so I can divide both sides by 1 plus CD. The B will now be by itself, and we'll have A divided by 1 plus CD will now equal B. We can find these zeros on our calculator by calling up our calculator, going to the y equals screen. Remember, f of x and y are interchangeable. So at this point, we want to type in the x minus 3 and look at the graph. We are on the standard setting of the graph from -10 to 10. To find the 0, 0 is the same thing as the x-intercept, so we want to use our calculator to find this point. We're going to hit second trace, choose number 2 for 0. We're always going to put our cursor to the left of the x-intercept, hit enter. Put our cursor to the right of the x-intercept, hit enter a second time. And when it says guess, just hit enter a third time, and you'll see that that actual x-intercept, or that 0 in this case, is going to be a positive 3. Now, we easily could have found that by setting the y equal to 0 and solving, but as we go on with this, we will need to increasingly know how to do this on the calculator. To find the 0 of the second equation I have here, again, the easiest way would to be set it equal to 0 and to solve algebraically. If I just add x to both sides, I'm going to see that x equals 6. To do this on the calculator, I'm going to go to the y equals. I'm going to type in a -x plus 6 and look at that graph. We're looking for the x-intercept. You'll notice that that's right here where the graph crosses the x-axis. Hit second trace, choose number 2. We always want to make sure the cursor's to the left of the 0. In this case, that is still going to be above the x-axis. Hit enter. Move your cursor to the right of the x-axis, or x-intercept. Hit enter again, and it will tell you the 0, or the x-intercept, is x equals 6.